The topic today is on say non-destructive testing techniques for concrete structures. Uh, so in this presentation, there are techniques which have been included, which are very commonly used, and few of you may be aware of those techniques. And there are certain techniques which are basically yes available, but not being used at that level. So I have just included, basically tried to cover all type of techniques which can be used for in our structures, basically as a non-substrate testing tool. Uh, yes, because you see that, okay, what is this NDT, non-substrate testing technique? Uh, because quality control of any construction project is very important. We have to basically see that whatever the construction is being carried out, particularly with concrete, so it complies as per the specifications. So those compliance with the specification is very important. uh, if we have to achieve a strength of say M40, if so we have to check at site, and generally we do for go for cube testing and all that, but then sometimes, many times, doubts arise because of the workmanship involved, depending upon the various factors which are not in our control, like your batching, mixing, placing, compacting and curing of the concrete. So, and otherwise, I think we will be talking about new structure as well as your this old structure also. So even otherwise, the with the passage of time also, the deterioration of the concrete occurs because of your overloading, fatigue and chemical actions, and then fire, explosion, weathering, etc. So we have to ascertain whether in situ strength is basically acceptable for designed loading system, for actual loading system, and for a projected loading system for a new use. Sometimes we may go for say additional heights or some additional different uses of the building. We want to put some machines or certain things over that. So there also basically we have to see that, okay, if we are changing the use of that particular building, we have to see that this whether the existing structure is having enough strength or not. So generally, in case of most of the things, I think we generally believe that cube strength is basically one of the criteria, one of the main criteria which we should on which we should depend upon regarding whether our concrete is meeting the required specifications or not. So, but there, I think we all understand, because of the factors of mixing, batching, curing, etc., and other factors basically which go in that concrete making chain. There you will find that the conditions may be different as compared to the conditions under which the cube is casted. So there, I think it may not be always true that the whatever the cube strength we are getting, it is there at the site or not. And then we have, in this particular program, we have talked about many like your precast elements also, basically, which are casted in the yard and then brought to the site. So there also, during transportation or during other things, we have to ensure that during their erection also, we have to ensure that nothing, basically no damage has occurred. And there also, these type of equipment are very handy and important. So because there is what that, okay, in the case of concrete, I think the parameters of the cube we were talking about. So the various factors which depend are the age. Basically, I think this PPC pozzolanic cement is having the slower strength development if it is used. Size of the cube is also, basically, it does matter. And then shape, whether cube or whether cylinder, but generally we are using cube. And mold of the material, texture of the molds used, compaction, how many number of layers, how many number of rows, dia of the compaction rod, then curing temperature. Generally, this is a one important factor which generally is not sometimes under control in our laboratories also. Then curing period also, for how much curing has been done for that particular, generally a difference is there. We cure cube for the 20 days, whereas the site OPC 10 days and 15 days for the blended cement. So that difference is also always there. Then moisture conditions at the time of testing are important. Type of the compression testing machine is also basically plays a role. This thing, direction and this thing, so rate of flooding also we generally this thing. So that is what we have to see, that how the tube fails. So here the node substrate testing plays a very crucial role in inspection and assessment of structures, maybe bridges, water tanks, whatever the structures we are constructing. And they can be applied both, as I said, both to the new as well as to the old structures to find out the various properties. But then I think we should be careful that not a single equipment can give you the complete structural performance data. So we may have to depend upon one or more than one technique for correct evaluation of the structure with respect to its quality and with respect to any deficiency that may have been there. So basically, this entity start from your visual inspection also, because the inspection by your naked eye is again the starting point, and then you go to the advanced available techniques for testing of the structure. It is, as I said, that it is not only used in quality control in routine inspection, but also in diagnostic investigations. And the various test methods, you may classify them as fully non-destructive, semi-destructive, and destructive, depending upon the consequent damage that particular test caused to the structure. So, and we have already discussed, quickly going through this slide, that okay, objective is the to carry out to check the quality at the site, to evaluate the structure with respect to its say compliance achieved, then estimating the compressive strength of the concrete, identification of cause of damage and source of problem, determination of the material properties, then determination of extent of damage, assessment of safety and serviceability of the structure, formulating remedial and preventive measures, then determining the position, quantity and condition of reinforcement, estimating the cost of repair or replacement, increase the confidence level of flawed destructive techniques, and structure evaluation after repair. So these are the things basically for which we generally use our this thing, and we can basically, depending upon the principle of application or principle of working of these equipment, we can group them in different categories. So here I have grouped them in 5 categories. The group A consists of surface hardness method, in which the commonly used is the rebound hammer test, which we always know. Then another test is the WINDSOR probe test, which comes under this category. Then, based on the dynamic or vibration methods, like your resonant frequency, this which is then ultrasonic pulse velocity, then acoustic emission, impact echo, transit dynamic, sonic pulse echo, and cross hole logging, etc. They depend upon your, because they are generally either we are creating some sort of a vibration, and that vibration travel in the concrete, and then we measure that particular vibration, vibration, and correlate with the property of the concrete. So this under magnetic method, the commonly used method is the reinforcement detectors and cover meters, where we go for basically we can find the reinforcement details, its dia, its spacing, the cover to the reinforcement also can be found by this particular. And group B consists of the electrical methods, under which basically principle of electricity is used, which basically I think mostly the moisture content measurement, your electricity, resistivity, half cell potentiometer, etc. are the equipment which come under this category. And group B is the electromagnetic methods, under which you have the radar come under this, and then your radioactive particular things, under which you can the X-rays, gamma radiography, infrared thermography, etc. Then permeability methods, which are there in the air, gas, water permeability test can be performed. And then you have the partially destructive test, which basically even WINDSOR probe is the comes under that, and pull-off test, break-off test, and the core cutting test. So they come under this person. Then we have the other properties. If you want to determine other chemical tests, where you can see that you can either you want to know the cement content, aggregate ratio, cement ratio, sulfate content, chloride content, alkalinity test, carbonation is again very, very important in many of the old structures. Then you have to go for crack measurement, pressure resistance test, etc. can be clubbed under this. So depending upon our requirement, how to select a particular equipment for our purpose. So if you want to determine the compressive strength, you will find that rebound hammer, WINDSOR probe, ultrasonic pulse velocity, core, capco, pull-out, and any one of these two combined methods can work here. So you can use either single one also, but if you want to have more confidence, you can use two methods together. Flexure strength, if you want to determine, you can go for a break-off test. Similarly, a tensile strength, pull-off test. Concrete quality with respect to its homogeneity, honeycombing, and voids, there you can go for is the ultrasonic pulse velocity test, which is again very commonly used test. That other tests are also there, which may include your pulse echo test, endoscopy, gamma ray radiography. Then damage, fire blast, and earthquake test. In case of that particular test, we find that the equipment useful may be rebound hammer, UPV, core test, and acoustic emission test. If we want to determine with crack, delaminations in any water tanks, bridges, or other pavements, etc., then we can go for this UPV test, acoustic crack detector, infra thermography, dye penetration test, X-ray radiography, gamma ray radiography, and crack scope. In case of finding the quality of the pipe, pile integrity test is is common, and this particular test may include the pulse echo, ultrasonic, crosswalk, and logging test in our testing. For finding the say steel details, we can go for this cover meter or say ferro scanner, etc. So there we may have to find the location, cover, and size. We can use rebar locator. We can use for corrosion is again very, very important in many of the old structures basically. So there you can use the half cell potentiometer, resistivity, carbonation, chloride content, and then condition assessment again generally endoscopic and board scope, etc. is included in this. Then your integrity and performance can be checked with the help of pulse echo, acoustic emission, radar and load test, etc. So coming to a certain details of their working and all. So first, one of the very commonly used test is the rebound hammer test, which is again covered in the Indian IS code 13311 part 2, and this is just shown here the basic components of rebound hammer. Basically, I think we need not go into details of this thing, but basically it depends upon the rebound action of this particular mass. Once we hit against a concrete surface, so it rebounds, and then that rebounds depends upon the hardness of the surface. So basically, this rebound hammer measures the hardness of the concrete, and we assume that harder is the concrete, better is the strength. So that way, the property that is one thing that okay, in any of the non-substitute test, we are not measuring direct property. Like here, compressive strength is not measured directly as in cube strength also, but here we are measuring the one property which is called the hardness. So we were measuring that hardness have been correlated with the strength of the concrete. These are the particular, I think, different type of hammers. Basically, it is again the calibration of these particular things are very important. This is the calibration angle basically. So we have to check whether our plunger or and the spring which gives the rebound action, that is having is proper or not. So basically, this anvil is provided with the rebound hammer. So we should keep on checking this plunger and basically spring with the help of the hammer, with the help of this anvil. So this is what they're showing that how this works. So this is the spring I was talking about. This is the spring part is very important here, because if a hammer starts giving wrong result, it depends upon the spring only, and also the quality of the spring of which material it is made will again determine the cost of the rebound hammer. So rebound hammer otherwise is available for I think 2,000, 3,000 something like also, but their life is very less. So that is what basically this particular spring is more important. So as we see that we measure hardness, and that hardness is basically of the surface layer, which is up to 25 to 50 mm. So we assume that if cover is good enough, so inside concrete is having the same property. So that is what. But then your rebound hammer test is influenced by many of the factors, like your smoothness of the test surface, size, shape, age of the test surface, internal moisture conditions, type of the coat segregate, type of cement, type of mold, and prediction of strength with the rebound hammer is plus minus 25%. And many times, if we have used the rebound hammer at the sites, and there we found that sometimes people come there and they generally ignore this moisture factor or some other conditions at the site, and generally if one person goes there, he may have a different results, and other person goes there, he may have a different result, because only that is what in any node solder testing I always says that our 50% and 60% you must depend upon the rebound hammer, but then also remaining, if you want to be 100% sure, so your assessment, basically the person who is carrying on the test, that is very important. And I have also observed many times one of the building we tested, which was tested by one party. So they have given a different result. When we went to test there, we found that the results are different. Then when we tried to analyze the things, we found that the person who he tested basically on a wet surface, basically. That there was a rainfall and all that. So because of that rainfall, the columns and concrete was wet, and so that it gave a different results. So that is what basically. And another thing in any of the node safety testing is we have to first provide reach some sort of agreement basically between the parties, that okay, what is the acceptance level, whether by simply going for a rebound hammer test we are able to we say that okay, this is sufficient. So there we have to see that okay, if we are checking say 100 locations and we find that in 100 locations about we say that if 80% locations were found okay, we say this is okay, or results are variation is within that much percentage, we say okay. If it is not there, we will say that okay, we don't agree to this, we go for some higher type of a testing. We may go for coat testing, we may go for capo testing, like that. We can basically we have to decide, we have to first mutually agree that what is our acceptance criteria for these entity tests. So this is showing that surface, this thing. So this is the rebound number which we read on that particular hammer, and once that rebound number, basically that is what is shown here. 25 layer is there only. So what is that the rebound number that has been correlated with the strength directly? Basically there is a ready to use graph. If the concrete is not very old, it is a new construction, we can go for the even manufacturer's graph also. But if it is an old structure, then we have to calibrate our own graph, because but otherwise also where our I think again, but you can generate your own calibration, own graph also. By if it is a new structure, you can always test it on the cubes and find out correlate with the rebound number, and the test that accuracy can, if you are doing with this sort of a precaution, you will be able to get almost 100% correct results at the site. This is a different type of hammer shown here. I will not go into detail of this thing. Okay, it's already we have shown. So let us not go into this. Is just that what are the different tests and all that also. So basically steps to be followed. So all members, they are to be marked with the grid points. Like another thing is how much basically at what stage and how much area to be tested. So this is also one of the generally we prefer that there may be about 5 to 6 locations, and on those 5 to 6 locations we take 10 readings. Out of those 10 readings we exclude 2 very high reading and 2 very low reading, and the remaining 6 average we say as a rebound number average, and then that rebound number is again read with against that rebound number we achieve the strength. So if we are basically given impact at a one particular surface, so it is not to be on the surface, on the same surface, it is not to be hit again. So again the energy of the hammer, because there is a normal type hammer, there is a which measures basically strength from your 10 to 70. Then there is a high strength mass hammer like your so which measures the strength for like which is a mass concreting, which is high strength also, and then for low strength also, like plaster work or concrete of low grade, I think less than 1020 we have got a P-type hammer. So different type of hammers are available. Then we have to basically correlate that, okay, statistically we have to analyze the themes and find out that the results are producing. Then we can find out the delimitation of the concrete cover. Basically, if you go for this test, you will find that the otherwise also, if you want to quality concrete, no, not going for the strength, this thing. So depending upon the REBOUND number received, you can classify the quality of the concrete from delaminated to very good. So hard layer, good layer, fair, etc. So if you are getting the reading between guys, you can very well assume those things. This is that graph. So again, sometimes nowadays the hammer which come, they are basically free from the direction of the heel, because the normal type hammer basically which we use is basically there that it is gravity force X comes into picture. It is against the gravity, it is along the gravity, it is zero direction. So here the different graphs are basically given for this. So here I think very simple thing is there. If you are getting the reward number 35, you go for this thing, hit it like this, you are getting the strength as 32. So that way the test is very simple and easy one. So this is N type. This is non-recording type. No, it is not available. N type. And this is again the P-type hammer, which is there. Basically, it is used for low strength concrete. Where plaster work also, it can be for brick masonry also. This particular hammer can be used to determine the strength. This is that M-type hammer, which I say that mass concreting. It is having a higher plunger, and basically for dams and where for air for payments, etc., we can use this hammer. The impact energy is here very high, and these are the just shown the different picture, different type of hammers, so you can purchase anyone. So that is the advantages. Simple, speedy, inexpensive method. Limitations are gives compressive strength up to limited period. So accuracy is plus minus 15 to 25% as per our code. But again, if you have basically properly calibrated, you are properly guessing, so almost many times 100% accuracy. Recently, we were doing one test of one concrete, and one of the third-party auditor came and he said, "Okay, you see that what is the accuracy of your hammer and all that." So he brought a cube, and then given the that impact was given, and according to our say correlation graph, we said that okay, this the strength will be in the range of plus minus 2. We say it was 42 plus minus 2. So he said, okay, let us test it. So he tested the cube, and exactly we got into the same day. So if your equipment is well calibrated and you are having checked it, I think you may get very good results which are there in the site. This is the another hardness method which is called is the WINDSOR probe, which is not in the Indian code, is not there. British code has 1881 part 2 is covered. Here basically what we do is these are the type of this is nothing but type of a gun only. So we fire these small shells into the concrete like this. We fix it and we and then fire it. So basically, depending upon the hardness of the concrete, so they will penetrate. So how much penetration is there, that can be measured on that or scale. So this penetration will has been correlated with the strength. So if it is a 2 mm, if it is a 10 mm, it is a 20 mm penetration is there or other things. So depending upon that, there are graphs are available. So the penetration against strength, you read that and you will get directly the strength. But only thing is, it is not a fully known safety test. It cover concrete gets damaged, but this is a very small, say 20 mm hole is created which can be filled afterwards. It is not a thing. So that is what measurement or depth of penetration matter. Penetration in surface concrete up to 75 mm is right. So prediction strength is again plus minus 20%. This is the ultrasonic pulse, another very commonly used test in our constructions. Even this is the older version is shown, but nowadays the new version has come, and there are nowadays I think many of the things are combined into one particular this thing. You go to buy a purchase a ultrasonic pulse test, and And these are the basically the components of these particular things. Are these are the probes. One is in this, as I said, it is based on the sending of the waves basically. Waves. So one these are the called the probes. So one probes sends the waves to the concrete, and other probe receives the wave. One is called the receiver, and that particular, I think here we note down the velocity, time taken to travel by that wave to travel a particular distance. Like if it is a beam of say 300 mm, so how much one end we keep this probe, other end we keep the other probe, and a transmitter we probe, other end we call receiver, and time taken by receiver is noted down. And in this, basically, the thing is that okay, that these the property of these waves is okay, is that they cannot travel in any sort of void, any if crack is there, if honeycombing is there. So they take a longer path. So we know that okay. So we have by our calibration system, we know that okay, if time taken is this much, we can either it is a qualitative test, but it can be used for quantitative test along with the hammer also. Because hammer, you have seen that only strength on the cover layer is determined. In this, we are determining what is inside the concrete. If the same uniformity is there, we can check by this ultrasonic pulse velocity, and if the uniformity is the same, then we can say that this particular system is the concrete is of good quality. So this is the basically this thing. So there are three methods. One is the direct, semi-direct, and indirect. In direct methods, basically waves are traveling in all the transmitter sends the wave in all the direction. They travel in this way. So one wave go there, receive there, other wave go there, receive there. This is all the time. So this is the one, and that is what we can do. It direct method is basically giving you any sort of information inside the concrete also. In semi-direct also, one you receive it, one you receive, you take this hypotenuse like this distance, because this is the distance, and this particular gives you the time travel and the strength, this quality of the concrete. In the indirect method, you can see that because waves are traveling in all the this thing, like your slabs, you cannot reach on the other side. So there, I think this particular thing is very important. So you can do test by this method also, by indirect method. But it is giving you not a very good information, because if surface is receive here, if you are putting it here also, like one is put it here. So waves, these waves are not basically traveling through the structure. Only these are surface waves. So accuracy with the help of this thing is not very there. But only thing is that okay, here the code also says we are doing this. We get the lower results. So we may increase our values by between 500 to 1000 if we do it by this methods. Okay, this is the graph in the given in the code, which basically depending upon the velocity you observe. This velocity, if it is more than 4.5, it is excellent. 3.4.5 good, 3.0 to this, and 3.0 doubtful. So that way we can read it. And basically nowadays, I think because this particular graph was made only for M20 grade of concrete. At that time, the higher grade was not there. Nowadays, I think the work is also going on to see that okay, whether this is applicable for high strength also, because in this case, it is seen that as we go higher and higher with our this thing, so there is not a proportional increase in the velocity. Like if you are going from say M25 to M30, M25 you may achieve value say 3.8, 4.0, and if you say M30, even then it may be 4.1. So proportionate, then even for M40 also it may be 4.2. So that way that increase is not there because what is this thing? Okay, that the propagation of the waves depends upon the how closely the particular all the say aggregates, coarse aggregates are packed. So only thing is that this particular test is very good when we say that okay, we are having honeycombing, cracks, etc. in that particular this thing. But for determining the strength, basically it is not a very applicable. So that is why we have to go for other type of test. So here I think we may have to identify that okay, yes, for many of the structures we have also carried out, we have found that if the strength is more than say M40, so we have achieved the velocities up to 5,000 kilometer also. So that is what that, but this is not as per the code. This is only as per the data literature available in many of the some of the research papers we have able to this thing. So basically, I think this code may be under revision, and you may get some this thing. So this pulse velocity will also depend upon type of the cement used, type of the aggregates used. Surface condition are very important, because you require to put your transducers on the surface, on that particular surface which should be smooth. Otherwise waves will be lost to the atmosphere only. Type of the mix, cement ratio, even reinforcement also, what is the stress has been given to that basically of that particular element is there. So but the application of this test is in determining the homogeneity and quality of the concrete, the presence of cracks, voids, other imperfections. Depth of crack also be determined. It is if it is almost the vertical one, so it is gives you a very accurate results. Changes in structure of the concrete which may occur with the time also, so we can determine by using this particular test the quality persistence of the concrete in relation to the another element. So if we have a cube, standard cube, on which we measure the that particular SAM 40 grade concrete we have taken, and we measure in the lab and determine its velocity corresponding to that particular cement, that particular construction at the site. If we are able to find out that okay, this is the velocity for that particular strength, we may find the strength also. And one of the interesting, basically, we did one testing for the one pre-stress bridge of railways. Basically, what the railways people do is, so they prefer to avoid any construction joint. So they carry out all the concreting operation in one single go. And it was a bridge of span about 30 meters, and it was a pre-stress bridge, and that pre-stressing walls and all that on which the railway line for slab to be laid, that was it is a box type structure it was. And they basically 30 by 7 height was 7 meter, and the thickness was varying from 350 to 450, in which pre-stressed cable holes were provided, and they cast it in a single go. No any basically was given in that particular thing, but they used the surface vibrators. So surface vibrators of not a required frequency were used at the site. So when they opened the thing, basically they found that it was a highly honeycombed, and to an extent honeycombing was that about two. Now you can take out that force aggregate by hand only. So that much, to that extent, honeycombing was observed in this case. So they were given the orders. Okay, you demolish all the things. So demolition cost was about say between 5 to 10 lakhs. Then recasting was again very high. So they said, okay, we wanted to try for rehabilitation. So they came to us and said, okay, what can be done? We said, okay, let us use this ultrasonic pulse velocity and this rebound hammer, because you are having the cubes at the site. So we calibrated our system with your type of a material. So we fixed the rebound value as 42 and ultrasonic pulse velocity at 500. And we provided all the 30 meter length and 7 meter height into grid of half and half meter. First, it was basically repaired by a simple cement grouting, so that all the surfaces were made smooth. Whatever the cement was to go, it was went inside, so all the surfaces were made smooth. And then half grid, and we carried out the test. On that test, we found what is the velocity in which grid, what is the velocity is coming. Then it was rehabilitated, strengthened by using this high strength epoxy, and that epoxy was put into this thing, and we found that whatever the grid, in that grid, when we got the velocity, UPV velocity as 5000 and rebound number as 42, we said this particular part is okay. So if there was still if still there was some deficiency, so we said that okay, instead of having that sort of a deficiency, this thing, go for more epoxy, this thing. So till the time we achieve the required values. So that way, basically, the bridge was completely rehabilitated, and it was long back, about 10-15 years back. So it was, and afterward it was very agree. And the cost of rehabilitation was about 2 lakhs only, not more than that. And and another problem which I think which occurred after that, because we did the epoxy coating, so it went into that because it was a pre-stress bridge. So basically the ducts, the wires which were there in that for tensioning also there also it got stuck into that, and that tensioning became a little bit problem afterwards. So those people basically I don't remember that, okay, because I was not afterward associated, but then they searched some sort of a chemical to dissolve that epoxy into that material, and then it was provided the required type of a prevention, and then it worked very properly afterwards. So this is a very good example how to use this test basically at the site, and you can say this is the ultrasonic pulse velocity. If you, as I said, if the bar is there, you wire the bar, and otherwise you can, and this is that you can relate your this bar diagram all that, and you can generate your graphs, and you can find out the particular dead velocity. What is that? The effect basically it is shown here. If it is a parallel, so about 3 to 4% higher values you get in case of a this thing. So ultrasonic pulse velocity. So bar is having some defects. This is the type of the so one road, concrete road is being tested by using this. This generally there was a crack basically here. You can see here. This is the crack. So we are determining here what is the crack depth actually. You can use this equipment to determine the crack depth. This is again a very simple procedure here. So this is what is the crack. So this is the use of that this thing. So I will reaction. The only thing is this velocity you have to determine this thing. And this is the equipment basically I have shown here. Okay, this type of equipment is there. This is that probes and all that also where you use them. And yes, I am not going into the working of that particular thing. I have already explained. Procedure, yes, you make a grid. Each grid point you thoroughly clean it. You have to apply a coupling grease or petroleum jelly on the surface to make it to have a proper content. And generally we get the calculate the velocity, but nowadays the equipment they give you directly the velocity only. You want to feed the travel path and measure the temperature. It will give you directly the velocity only at the side. So this is what basically you can use this particular thing also. I have already shown you these things are different. Researcher they do different things. So this particular thing can be used. So generally you can find a lot of data available there. So that data I think you have to basically properly mark it so that you can identify the locations of poor quality at the site. And this is what I was explaining that determination of your, if the two layers are there, different this thing, if higher layer, lower layer. So you can find you can put one transmitter here, receiver point you can keep on changing. So basically, as I said, waves are traveling. If wave is traveling here, this wave is traveling in this direction, this wave is traveling like this. So once it enters into other media, you want to determine depth of that concrete also. You can find out also. You prepare with the distance your time travel, and wherever the change you will find in that particular something you will get in this particular curve. So that gives you the distance at which that depth is changing. Quality of the concrete is changing. It may be M20, it may be M30 grade of concrete at the bottom. So you can find out basically at what depth basically that particular thing is changing. This is what same thing is shown here. So here I think the straight line is changing here. You can say this particular is the damaged layer. This is the sound layer. You can find out, and this is what basically you can do that. This is the concrete quality basically SNA. So correction factor may be applied. Again for the reinforcement I have already shown. This is to find out the crack depth. Basically, what you do is you put first your probes at a x distance, and then put the probes at your 2x distance, and then you determine when double the distance, and then or once you do that, automatically nowadays that advanced equipment gives you directly the depth crack also. So almost vertical or near to vertical cracks can be determined. The depth of the crack can be determined by this thing, and we have basically used this equipment to in J&K, Jammu Kashmir, where the railway line is going on. So there, I think many of the new say some abutments and those things developed some cracks. By, as I said, by placing an order also. So we just used that UPV to find out how much is the crack depth, so that basically you can decide this width and depth is important because you want to repair it by epoxy and some other things. So you must know, okay, what type of epoxy to be used, how much viscosity should be there. So that way, basically, this determining the crack depth and crack, this is very important. And after repair also, basically, you have to same procedure you have to follow, because if there is any crack after that, if you are getting zero, basically this thing, so only then I think your repair is successful. You can go for say cube strength and all that. Also, you can generate your own graph with respect to your pulse velocity, and you can find out what is the strength basically achieved at the site also. So generally, you can use most of the times UPV and hammer is used in combination. So here, this particular gives you, if you are getting high UPV value, high impact number, no corrosion, basically no corrosion is there, medium surface demolition has already got low UPV values, not corrosion pros, however, confirmed, it is be confirmed by the further test like chemical test and calibration. Very low UPV and very low impact number, basically it is already corrosion is occurred, so we may acquire further this type of test. So these are the factors basically which affect. We have already discussed these factors. Limitations depends upon operator, his knowledge, interpretation by a experienced engineer. When the structure is met, it does not give the reliable results. So basically that is what. And similarly, actually, one example I can give you here is one of the multi-story buildings for which we tested the column. So one of the consultant, he gave the result that your quality of the concrete is poor and all that. And when we tested, we gave him the strength is good, and using both this remote hammer and UPV. So it was a almost contradictory result. So when we went at the site, and so both of us went at the site, and then we discussed it. We found they have tested on on area which were already in a poor condition, and we tested on the good concrete. And we have in our report we have given us this is not basically up to the as per specification. It requires remedial action or maybe whatever the decision is to be done. But ultimately, we were also not wrong. The other party was also not wrong. But yes, how the test was, where test to be done. So that way, it is important to. This is I think now pull-on test. Actually, basically, you can determine that is subjected to concrete to shear and tension. It requires pre-planning because you have to insert the disc here in this thing. And this can also be pull-out test. Basically, we make a hole into that particular thing, insert the disc, and then after pulling this thing, we pull out that particular disc into that system, and that pull-out force, how much force is required to pull out that this particular disc will give us the strength. It is again a very commonly used strength. Basically, you can find out that okay, this is the cone of failure, this is the embedded sort of a concrete, the pull-out test is there, and this is again a very accurate test. If you compare it with that accuracy, it is almost comparable with your core test. Even core is also not very sometimes reliable because core is taken at the site. Sometimes you do not prepare. I think we come to later why to discuss it here only. So that is what basically this is the CAPCO test. This is that. This is the that particular whole assembly arrangement. So prediction of strength is again almost plus minus 20% as per the codal this thing. So I think this is that in use. Particular, you put it there, insert it, and then you find out the failure. This force to pull out that particular system will give you the compressive strength. So this is what basically you can see that if you compare it with the pull-out test and with the cube strength, you will find it is almost in that particular range only. This is a failure mechanism is shown here. So this is given you this thing, the strength and all. So you can see that this is CAPCO test. These are the codes and these are the Schmidt hammer test. Schmidt hammer test you can find sometimes very high, at some places. This thing not very comparable. But if you compare these two tests, so there you can listen. But then if you, this is basically with the general graph, it has been prepared. But if you have calibrated your system with this, you may get the curve same also. We have tried many times with our MTech students also and in our lab also. So we found that but accuracy wise, this is almost very close. This is another pull-off test. This is to determine the in-situ tensile strength test. Sometimes we have to find out also. So in tensile strength, so there also this particular test is again almost we insert a disc and that industry is pulled out, and basically we find out that this is what your pull off test is there. So there the once you sorry put the disc, you with the help of this lever you put it, and this force is displayed here. That force has been correlated with the pull off test. So many times like we are go for carbon wrapping wrap system. So in one of the buildings here, I think even Amit was also associated in that building when we tested this Infosys building in Chandigarh. So it was having a pre-stretched slab. Slab was again by the technology which was discussed by Usha Martin. So there were no beams and the columns were above M40 grade. And when basically there was no basically proper site engineer, one architect was there, so he was finding out and he was basically checking the quality. So one day when one civil engineer visited, found that the strength by a cube was almost not accurate. It was near about M25 against M40. And then we tested all using all our system and all that also. So we found that yes, strength was not more than M25. So we carried out, we suggested, so their engineer suggested the strengthening by carbon wrap system. So carbon wrap system was used, and then basically we use this carbon wrap system. We use this pool of test to test that carbon. This thing. Even one of the green building in Chandigarh, Godrej, that has been tested, which was provided again strengthened by carbon wrap system only. So there to check out whether the bond between the concrete and this is okay. We use this pool of test there also. This is a complete assembly of pool of test. And this again a break of test, basically again almost similar way it works. So it is to determine the flexure strength of the concrete. Not very commonly used, but yes, these tests are available. So they have got a very specialized sort of applications. This is the core test, which we say, which is covered under 5 and 6 of our Indian code. And you go to the side, we have the core drilling machine. With that, you drill out the cores and take out the steps and all that also. I think I am going a little bit slow. So basically, these are the tests. Basically, core samples can be taken for strength determination, void estimation, petrographic analysis, or other parameters, chemical analysis, etc. This is shown here. So core sampling for UPV test also we can do this thing. So interpretation, basically we have to done basically whether what type of a core we have taken, good quality core, it is not corrosion prone, if there is a presence of surface voids and low density, so that way. So basically the test is required that minimum dia core shall be 3 times the nominal aggregate, core length of the dia ratio shall be between 1 to 2, specimen shall be soaked in water for at least 28 hours, and you can say that minimum average cube strength is again should be greater than 85% of design grade of the concrete, but no individual core shall have. That is the same class which we used for our cubes also. The accuracy is again plus minus 12%. So it determines the in situ strength and basically chemical test also can be their core also can be taken, and for inserting boards etc. we can do for this thing. So then another commonly not commonly used, but another type of equipment. Now we are coming to some advanced equipment in construction, which what we used is the one is the ultrasonic thermography. So it is basically used for thickness measurement, because many times you have a member, one side is available, so there you want to go for thickness. So ultrasonic pulse waves are they are received. Some transducer will send the wave, other transducer will receive the wave. The time taken by those transducer to travel all this thing is depending on the this thing. So again, we can deduct the wires in grouted tandem ducts, deduction of poor quality bond in overlays and repairs, deduction of delaminations to basically if they are there, bonding details of the wires are high coming in the concrete, assessing the state of the enforcing bar in the concrete. So we can use this particular thermographic method, which is again a pulse echo method using transmitting and receiving transducer in a pitch catch configuration. One transducer send a stress wave pulse and other transducer receive those waves, reflected waves, and there are C scan, D scan, etc. are there. So basically A, C, B, C scan. So those scans are basically read in their software provided, and with the help of those. So this is type of the equipment which is used. So these are the basically probes. Half probes act as transmitters, other probes act as a receiver, and that is what they are thrown here. So here waves are sent and received back. So you can show that these particular waves, that is what is shown here. So if this is any sort of a delamination, any sort of a crack, so here the waves are received at this length only. So they are not penetrating the full depth. So that way you can determine the depth also. If any delamination is there, you will get that with the software, you will get a different color here also. You can identify it, okay. This is the what I said is the BAC scan, B scan. So under this you can identify what is the at what location the some crack, some say delamination is there in that particular. This is what you can see. Corrosion can be interpreted by this particular system also. Okay, in between this some other tests are there, but okay, somehow I think this carbonation test. Carbonation test is a chemical test. So basically, the normal value of pH value of concrete is 13, but when the corrosion occurs, the pH value reduces to it's near about 9, 10 or something. So basically, this carbonation is basically very high in dry weather, but possibility of corrosion is less due to moisture content. So basically, phenolphthalein indicator which we use in our modern lab is a good sort of a this thing. If it is if gives a this color. So this is not a carbon probe, but if you spray it on there, it becomes colorless. It is a carbon probe. This is simple, your volumetric type of a test analysis in there. So corrosion occurs. Why this thing? I am not going into detail of this particular thing. Okay. But as ferrous changes its with due to reaction, ferrous convert into ferric, corrosion starts in any structure. So this is the one is the carbonation test. Other is the basically corrosion testing is done by the corrosion mapping. Half cell potentiometer is the test. Here we have a cell here, and which is filled by the copper sulfate, and that particular we supply the electricity current. We have to provide a open reinforcing bar, and once we complete the circuit, the current will flow. That current is measured by a voltmeter. That volt reading has been correlated with the extent of corrosion in the concrete. So we can basically form a contour, and we can study whole particular structure, whether which areas are having how much corrosion in that particular location. So this is what basically you can see that this is that half cell potentiometer, which was made by us only taking a shoe polish sort of a thing and a sponge and all that. Also fill the copper sulfate, use the ordinary multimeter only, and use that particular thing to study that. But nowadays, but otherwise, in market also this thing is available. But you can in your lab also you can make very simple sort of a thing, this particular thing using a multimeter. This one will cost you more than 1,000, 2,000, and we have tested about long back our whole near about 100 buildings in Chandigarh, where when we were carrying out a project on extent of determination of buildings of different ages in Chandigarh. So that is what this particular graph can be used to find out whether this particular how much voltage reading you are getting. So that has been correlated with the corrosion probability in the structure. These are the factors which affect basically quality concrete cover, all that also. This is the graph basically which comes with the software and the color coding, and this color coding will tell you what is the voltage reading and where the corrosion is more, where corrosion is the less. You can use this particular graph also for this purpose. So again, I am not going to this thing. This is same thing. Okay. This is just shown. This I am not going basically where how to use that also. I think this is that the surface unit also which we are having in our this thing. This is the resistivity meter. Corrosion may we have to make a say half cell potentiometer may, because we have to make a cell, we have to see a bar also. In this corrosion by resistivity method, you can find that you have a sort of a rod where I think it is placed on the surface and it gives the resistance. That resistance, basically these are the, you can say, probes are there like this. Those probes will send the electricity current, and that electricity current basically it means the resistance to flow to the current, and basically that is required into again a resistance ohms. We are getting the reading, and that resistance has been correlated with the corrosion distance. So basically that is what in ohms centimeter we are getting this resistance. Depending upon these values, we are classifying it how much is the corrosion probability in that particular structure. So here also you can use this mapping, color mapping and lot also. This is again the resistivity meter we are having here. Let us not go into detail of this thing because there are certain other. This is the impact echo test. Basically, here the principle of working of impact echo is it is a receiver adjustments to impact point monitors with the arrival of a stress as they undergo multiple reflections between surface and opposite side of a plate like member to or form internal defects. So frequency analysis permits determination of distance to reflector if wave speed is known. So basically it is used to locate a variety of defects within the concrete elements such as delaminations, voids, honeycombing, or measures the element thickness also. We were trying to what one this latest equipment is there basically, but we could not get that. So this is the one. Basically, what we do is we with the help of this, we send that some impact is given on the surface. That impact is basically travel down. If any travel deflections are there, so that will be recorded with in the software, and we were able to from the software we were able to read it. That okay, this is what basically it happens. That okay, you give an impact, that vibration travel down, any crack will be reflected from here. If it is a completely good concrete, it will not. If it is a honeycomb concrete, again it is reflected. So you can find out with the help of this pulse echo response any delineation and avoid honeycombing at any depth. So this is what you can use this particular test. This is a sonic echo also. This is again the same type of a test where we are using a hammer for impacting the surface and a receiver basically to monitor the reflected stress waves. So basically it also determines basically very useful in deep foundation like piles and piers and determining the location of cracks in construction. So this is what basically this is the pulse echo test. So with the hammer, this is a pile cap on the pile. This thing on that you are giving a vibration. This vibration will travel down, and based on the this stress wave propagation, you can find out basically for time travel taken out, then you can check the integrity of the pile, how much good is pile. So it is a very good test for to find out the very quick test also, because other if you are doing the load pile load testing, so it is a very costly time consuming test, whereas in this by this test you can check almost 50 to 100 times in a day. It is a very common test, very simple test also. So pile shall be trimmed, cut off at the for pile diaphragm. So additional readings are to be required, 1 or 2 readings for simple. Lesser than that, we may depend on the single reading also. So this is the one basically. So we can check the cast in situ pile. Basically, they should be tested. Should not be tested normally before 48 days of the casting, and not before 7 days. So response, a reasonably correct assessment of stress wave velocity of the pile concrete is essential as an input. So we have to see that okay, it is correctly going into the concrete, and complementary UPV test may be carried out at the head of the pile in order to arrive at the speed propagation also. So it has got some limitations like evaluation is approximate, not exact, no information about load carrying capacity of the pile is there. If you are very particular that if your quality is okay, but if it is a want to see that okay whether that load will be able to additional load will be able to carry, it is not possible to do that. So minor deficiency are ignored. So so that way basically some information it may not be able to identify. So we have to, it has got its own limitations, but at the same time it is a very good test to find out whether if some like in casting situ piles some problem has occurred while casting, concreting has not penetrated to the surface. So there we can do this particular test in a very issue way. This is what the hammer, you can say the similar way, I think, which I have shown that these waves goes inside the waves, and these waves, if some like this type of a structure is there, so they will come back from the surface only. So we can find out basically that is what is happening and what particular location. This is that pulse echo. If you are getting the waves like this, so with the pattern of these waves, you will be able to find out. This is a lot of vibration, showing a lot of different sort of this thing. So this is a straight curve means this is what you can say different. These type of imperfections can be located here. This is a cross-hole logging. This is very similar to ultrasonic. Only thing is that okay, we have to provide in the foundation holes which are drilled after the construction. So there we can locate the low quality concrete and with the help of this thing. So you can take the permission to drill this thing, and basically that is what this is again nothing but a UPV test only, and this is what the cross hole. Here you get basically relative energy, so arrival time, and you have this energy, and that energy particular has been correlated with your imperfection. It's a GPR penetrating radar. Basically, it is again very much similar to your ultrasonic pulse echo method, except that electromagnetic waves are used instead of stress waves. So it is a geophysical method. I think many of soil engineers, they must have used them. So it is a non-destructive method using electromagnetic radiation in the microwave band of the radio spectrum and deflects the refractive signals from the subsurface structure. So different layers are there, so different this thing is there. So basically it will consist of antenna unit, control console, display, monitor, and data is collected with the help of rolling on the surface by moving the antenna, and then low frequency units. Basically, they offer greater depth penetration and they are better suited for civil engineers. So basically, we can use them for geological investigations, whereas high frequency units are used for high resolution while working for concrete and this. This is what basically you can use this transmitter antenna is there, this is a receiver antenna is there, you throw your waves into this thing, this reflecting energy, and this is received by the antenna, and based on your this thing type of the surface and this thing, you can identify that your depth and all that. So it is again a limitations, and basically operation is the thing you put it on the take on the surface, you send the waves inside the building, receive it, and then carry out the analysis. So basically, depending upon the type of the strata and strata, you can find out which the penetration can take place. This is what basically you can say radar media and this thing. So basically, you can this particular type of identify the thing, and this is just again shown that the particular type of locations taken, but application of this particular thing is that to locate the pipes, cable below ground level, buried foundation, locate steel reinforcement, find internal defects, again locate zones of water penetration, determination of thickness of the member, then find integrated concrete and masonry wall, mapping of surface and rock layering, etc. can be done by using this. Good for your listening. So this is again the radar is shown here. So this is what you get the thermography and all that also, and this type of a software you can analyze the things by taking the data from the site. So this is what these are tension cables are shown here. Slab thickness can be determined. And another use is the infrared thermography. Now, I think we are very much here on thermography. I think because of this coronavirus, I think many places this is so. This similar way, it can be used in our building also. One of the buildings actually we have used this infrared thermography. Is a thermal camera only. So with that camera, we take the picture. So basically, if it is, it depends upon the temperature also. So temperature where lower temperature is there, that means this is a moist area. So it gives you a color coding as per the software, and from that color coding, you can identify the areas of where the water is there in something this. That way, basically, it is an important sort of a this thing in investigations or particular buildings. So we tested a very timber building using investigated about 150 years old timber building by using this thermal camera. Because it was located in Shimla, where we wanted to it was a timber structure, so we used these thermal cameras to find out that what is the moisture level of moisture content in the timber. So there we could identify areas which were having the higher moisture, which were having the moisture affected by moisture affected timber, and those were replaced, and building was rehabilitated using this. Our results are also. So this is what infrared radiation technique is there. So basically, this is a camera, and it is just gives you a principle that. I think most of us know we are using a simple camera to measure the temperature of the target object. And this is way how can you see that if your temperature is different, because your body temperature is different, it is giving you different color. So that way, basically, you can thermal patterns on the skin surface can be indicated of the disease, are sometimes used to aid in medical diagnosis. Now it is a very common, I think, because of the coronavirus and all that. So, so similarly, it can be used for buildings to determine moisture contamination. Even concrete integrated inspections. Locate missing or damaged insulation. Identify air leakages. Evaluate thermal performance or retrofits. Locate radiant heating wires or pipes. Deduct the elimination of the concrete pitch. Locate the identity of the mold growth areas in the particular building. So you can see that different areas give you a different temperature. So we can identify the building defects by taking the picture, bring this thing and this thing. So heat loss from the building facade in thermal insulation. In determining that also, you can do that also. Your temperature, higher temperature, lower temperature. This is a leakage in the water tank. Even this technique we have used in Jaipur Amerfit also. There was problem was of a there was a crack in the foundation basically, and water was seeping. So we could, and one was a retaining wall. So the settlement was taken. So we were not able to identify what is this happening. So we had the actually MTech students basically he did this particular project there. He identified the problem, and then we helped that particularly Amarford to find out that okay, this seepage, water seepage is one of the major causes in that particular getting the cracks in that particular fort. So they have been used basically. That is what infrared thermography is shown here. So crack mapping, depth, width of the crack, determination. We have the crack scope. Many of the places we can find out. Endoscopy, as we is nothing but ultrasonic test only, but we send it with the help of the wire. We send deep into the hole, like water, like your fall ceiling, etc. If we want to locate your wire tubes, your pipes, etc., we can take the pictures. Endoscopy can be done. Underwater inspection can be done by this thing, and sometimes we have to see the vibration monitoring also. So this is basically that is what we have to see that what is the effect those vibrations, particularly in old building, old structures. We have to find out. This is a moisture measurement again, which can be used to measure the moisture content in timber, concrete, plaster, and masonry. Radiography, we have already discussed something, not a very commonly used test. We can use X-ray or gamma rays that can pass through stress, but basically that is not a site test. You have to bring it a thing to your lab only. So quickly, I'm just giving you, because not very commonly used tests. Even I have not used them. I have taken it from the literature, and you can see that this particular their tests are available, but yes, not, but they are in the laboratory only, and not very this thing. Because radiography means exposure to radiation, etc. is there. So basically, but for many old structures, many this thing. So X-ray unit. This is that X-ray unit. You can do that. This is the test to find out the air and water permeability at site. It is again a test basically which because at many places we have to find out the water permeability, water penetration, etc. We have to. So if our cube has failed this permeability test, so there I think if concrete has been casted, you have to find out what is the penetration of the water in that particular thing, whether this permeable limit or not. So this test can be used. So here what we do is you fix the our system here and put the water, and then after 5 to 10 minutes and 15 minutes, 20 minutes, half an hour, for after every 5 minutes we required this with the pressure gauge, we required the penetration of the water and determine the water permeability. Similarly, air permeability can be determined by using this test only. The gas can also be seen. Then the chemical test is the colloid content test, which is again important in old structures like colloids, maybe new structures also. If your cement is containing colloids and all that, so there also you have to find out colloid content. This is nothing but volumetric test. You go bring the cement powder and carry out the say your titration in the lab by using the chemicals and all also, and find out what is the colloid content as we determine in our system. So this is the rheometer basically. This you will find out the is also. Then majority method is the one method which is again for a in situ test, not a this thing. So new construction where, because if you want to see the strength development, so there you invent this particular sort of a equipment development into the concrete and record the temperature generated. So that temperature generation has been correlated with the strength development also. So this is the maturity method, which is again called this is what I said, maturity and your equivalent age at the particular strength. So basically you can find TOMOGRAPhy is called, so you can determine the strength development with the help of this particular instrument. So it can be called concrete maturity test also. So you can use that also. So chemical test we have already discussed. This is the carbonation. This is again the pH value. We already discussed. Chloride content we have discussed. Sometimes, okay, what are the number of tests to be carried? Minimum number of tests. So basically, standard codes 13. The Bone hammer, as I said, about 10 to 12. Ultrasonic pulse velocity test, 2 tests. WINDSOR probe 3. Pull-out test 4 places. Over location pull-off 4. Break of 5. So we have to see that, okay, we take this one, take an average of those things. And this is one thing which has been compared with the medical science versus component supply. So orthopedic doctor is your structural engineer, pathologist is your NDT consultant, surgeon is your again structural and rehabilitation consultant, medicine is construction chemicals, stethoscope is your bone hammer, sonography is your ultrasonic pulse velocity, biopsy is core cutting, plaster for fracture is the jacking to the member, and this almost ultrasonic pulse velocity and this sonography is very much similar basically. Only thing is they are very, because it is attached with the own body, more sophistication has been reached. There it is something different. So this is almost a different sort of a application and all that, and this particular thing, yes, we can compare it, we can do that also. This is what some of the case studies like corrosion determination, heavy plant. This is that, okay, how almost completely the column has gone. This is what has happened to one of these things. So these are the, again, bridges, the water tanks, etc. So this is regarding, I have not discussed many case studies, but in between wherever I found it suitable, so I found it a useful one. So so now we can go to question. I think I have taken about almost. Hello, Amit. Hello. No.
Sir, which testing method will be the most affordable and accurate?
Which testing method is more accurate?
Accurate and affordable.
For what purpose basically is not clear, but I think I would already explained that any means we have to first find out what is our objective of carrying out the test. So based on that we have to select the test. As far as accuracy, I have already said even bone hammer is almost 100% accurate, even you are, but there we have to like interpretation of entity result is very, very important. How we want to carry out the interpretation. So if it is only a, say like a bone hammer you have used only for with the calibration with your manufacturer's graph, it may not be accurate. But if you have used your own calibration, it is almost accurate. So accuracy will depend upon for what purpose we want it to. If it is simply say quality control at the site, I think bone hammer may be enough. But if it is to find out how much is the strength is basically, then we have to use some Capco or say your core testing also. So it will depend basically.
Okay, sir, please comment on NDT of mortar joints in masonry.
Means if you want to determine the strength in masonry, so that way basically we can find out, you can use this P-type hammer for this purpose.
Okay, sir. So how can we calculate dynamic elastic modulus?
That you can use by even UPV also. If you know the strength and you know the parameter also, you can find out this elasticity using this ultrasonic pulse velocity.
Sir, is there any?
Yeah. Carry on.
So is there any code?
Indian codes of only ultrasonic pulse velocity and remote hammer are there. 13311 part 1 and part 2. Others are having all the codes are basically either British standard or ASTM standards.
Okay.
Indian standards are not there.
What are the different sensors used for structural health monitoring?
Sensors, I am not able to, will not be able to answer this question, because sensors we have to develop basically, like one of the thing is in acoustic emission test. Basically, what we determine is the propagation of the cracks. So we install the sensors there, and those sensors basically are if there is any vibration, so any sort of a cracks occur, so they are recorded by this thing. So these type of sensors, I afraid I am not the correct person to answer that question, because I am the user of the equipment. So type of sense I can't comment. But there are the embedded system there. I think the work needs to be carried out. I think the stress strain gauges and all strain gauges, they can be the one basically the simple strain gauges. It is again a type of a sensor only. The simple strain gauges which we embed it in the concrete, and once we if we exceeds that our stress and strain, so it basically gives you the reading and all. So basically that is our advanced versions, maybe that embedded systems, using our embedded systems, basically there we can use the to find out the latest and better sensors in our concrete structures.
So is NDT suitable for damp area of concrete?
If NDT is suitable for damp areas,
Damp areas of concrete.
generally we should avoid, because but if we are able to find out okay how much is the moisture content, and then we can carry out that what is the correction factor, we can use on the damp surfaces also. But generally if we are to go for some diagnostic techniques and all that also, so we don't want to use them in that very damp conditions.
Okay. So can we perform MAPCT test using NDT?
MA
PCT test using NDT.
impact test. And impact test is there. Yes, is what I think we have explained. Impact eco test and even pile integrity test is impact test. We can using those type. Impact means that okay, we are giving some sort of impact which generate some sort of a vibration or say stress waves into our structures. Or those waves basically we due to impact we measure them, and we find out the quality, say voids and honeycombing etc. into our structures using that.
So in case of UPV and rebound hammer test, calibration charts need to be prepared on site, or we will be using these from the literature.
That is again, if you want to go to almost full accuracy, as I gave an example of that particular Pistas bridge. So in there, I think you need to calibrate your at site only. But if it is only a quality check and all that also, there you can use the manufacturer's provided calibration also. So that is what basically interpretation and using particular these type of a test between the two parties. It has to be agreeable. Suppose if I say that okay, you won't hammer test. If I am getting my bond test say carried out the site almost these values. So with 5 to 10% or 15% variation, I am acceptable to that. If I say if it is beyond 15%, we have to agree that then we will go for UPV test, or you will go for this core cutting test. If the core cutting test is again, we say okay, we are not able to achieve the desired values, then we will say okay, demolish or strengthen that thing. So that way, basically, we have to interpretation of the entity or test is very important from that point of view.
So during radiography test, which region absorbs less radiation?
Which region absorbs
Less radiation. During radiography test, which region absorbs less radiation?
Basically, here again, because we are determining any sort of a delaminated concrete and all also, so basically that radiations which are there, so which is a affected part, so that will be those radiation will not be basically showing that on X-ray. Basically, we are carrying out, we are seeing the X-ray like your internal body X-ray is there, so same way we are doing that, and when we are sending the radiation, so these radiations again depending upon the deflection or deterioration, so their travel may not be as per the standard one.
Is NDT is more accurate than destructive testing?
Uh, I have answered that question earlier also. So NDT is like even destructive test. I started with the cube testing only. So cube testing means that okay, under very controlled conditions, whether so there it is done, but the entity is carried out at the site, so it is not, it is almost as accurate as the destructive testing.
So, how to calibrate the rebound hammer for an old building where we don't have any design data available?
So basically there you have to take the cores from the site. So on the core you put the you take the remote number values, then in that and see that under in your CTM machine how much strength you get. So then you generate your own graph with respect to that building. So you have to make the if there is a carbonation, you have to make the correction for carbonation also, and then you can generate your own graph and you can use that particular thing remote hammer values to for that for old structures also. Many times we have used it for many structures. Basically, it's not that this thing. Many even for bridges also we have used this remote hammer test. I think Amit and myself carried out about say 20 bridges in a stretch from this in Himachal Pradesh. There is a place Bilaspur, from Bilaspur to Pandor Dam. So we carried out about 20 bridges at that time. This new uh, plants, this dams were coming, so heavy machinery was to be carried out. So they wanted to check the existing strength of those buildings, those bridges. So we carried out testing of those bridges using this particular thing only.
So, is there any testing device which can help to find setting of cement in cement plants, especially as quickly as possible to check the batch when cement is manufactured?
I don't understand if there any testing
If
device to find the
can
cement.
to find setting of cement in cement plants.
Uh, it is for concrete. It is for concrete, not for cement, basically. But true, you can. If I think if it is having, if he's saying about concrete only, so then it is at site. This is the one basically you can determine. Yeah.
Okay, so what method of NDT can track formation of nuclei crack?
What?
What method of NDT can track the formation of nuclei crack? Yeah, nuclei crack, yes. Nuclei crack. Yes, I guess,
Then
yeah.
look, any type of crack, basically, if we are finding out by different methods, I think they can. They are even simple ultrasonic pulse velocity can also find out the crack. But basically here he meant that nuclei means that if some due to nuclear power some cracks have occurred. So there I think you want to, but these are the same methods will be used. Two answers, same thing only. If it is a nuclear crack due to some nuclear thing, also same methods. And yeah,
Who can perform NDT? Can we rely on skilled labor to perform tests?
No, 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 no. I have said that the person, a trained person, is very much required to carry out the entity, and where to carry it out, at what place to be carried out, how to make the surface for conducting the test. Basically, it is important. You cannot rely on. I would say it has to be technical person who is having the enough training, good training, basically for this purpose.
So, can we test during construction itself and rectify it before the commissioning of the project?
Yes, yes. That is the purpose basically. The quality control is one of the major application of entity tests. We get many times we get many such consultancy where I think the tubes have failed. So they wanted that one of the very interesting case we got was in one of the MES locations. So there they were constructing a multi-story building, and when they came up, they casted the plinth, and when they went up to 2 stories, and after that, what they found that that below the plinth beam, a gap of about 100 to 200 has been left in most of the columns. That was not filled by this thing. So there, I think afterwards, then we recommended a sort of a re-strengthening of the column. So we provided the extra concrete, extra reinforcement, took up to the plinth level and beyond 1 meter above also, and then it was recasted and tested whether the bonding and that with the new and old concrete is okay and all. There were about 200 to 300 columns were rectified and tested. So rectification and testing is, yes, it is to be done. One of the plants, the cement plants, what they did is basically it was a, you can imagine the beam size was say about 6 meter and like that basically. So they what they did is they basically to enhance the plant capacity, they put additional machines on the top, and because of putting those machines, that the lot of cracks appeared on that existing beams. And size, I said about 6 meter, 8 meters, like that beam size was there. So basically, that after identifying the cracks and all, also they were strengthened and checked by these entity equipment whether it is okay or not. So we are always using these equipment, and always good to use these equipments as a third party wherever we are using carrying out third party inspections and auditing also. So there we take these equipment, carry out the random testing, and we will tell them okay, if it is not okay, you go for this, you go for this. So that way it is, you can use them.
So, what are the limitations of NDT, and is one reading enough, or we have to take multiple readings for more accuracy in NDT?
The limitation of each method I have discussed basically equipment wise. The remote hammer has its own limitation, and ultrasonic pulse velocity has own limitations and all that also. And what is the next part?
Is one reading enough, or we have to take multiple readings?
No, I have yes, that also I have given one this thing that how much readings for rebound hammer, how much for ultrasonic pulse velocity for each test requires how many readings. It is covered in that slide.
It's the last question. Whether position of bar location is necessary for performing rebound hammer test?
No, 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 no. It is not necessary. The rebound hammer test is basically it is giving the cover concrete only, strength of the cover concrete only. So that particular steel has not any impact on that value of the rebound hammer. Not necessary.
Sir, there are no more.
Okay.
Thank you, sir.
Okay, thank you. So we will. There are two sessions, or what session we are finishing? What? Okay, okay, okay. Okay, so I will. Whose session is there now? Okay. Right, 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 right. ठीक है. We will see that.